One way that heat transfer relates to my everyday life is my commute to heat transfer class at 8 a.m. every Monday, Wednesday, and Friday. I've made this commute about 40 times and noticed that at least 80% of these commutes, my face has been blistering from the cold every single time. So I got to wondering, how does heat transfer relate to my bike ride to heat transfer? All that was needed for this apparatus was a B-cycle, which CU graciously funded with our tuition money, Colorado winter weather, which we certainly got this past winter, a digital thermometer, which was bought from Amazon, and my unwilling poor face, which was subject to this every single morning. The first step through this experiment is to define our initial and our boundary conditions, which we will do using the thermometer and the initial conditions of my skin and the outdoor temperature. The outdoor temperature at the time of the recording was 33 degrees Fahrenheit in Boulder, which was definitely uncomfortable and made my face hurt. Taking our initial skin temperature, 96.7, that's kind of cold, but kind of makes sense. I've been out here for a minute or two. I'll be attempting to maintain an average speed of 11 miles an hour on this trip. Taking our temperature after our short little bike ride, you can see my face is much more red than when we began. It took about 5 minutes and our average speed was probably closer to 12 miles an hour than 11. It says my skin's 66 degrees. Hopping to our ease code, we could do some calculations to see if our experimental data actually fits with our calculations that we would learn in heat transfer. So here you can see we defined our initial conditions. All these properties I looked up just for the body and the head on the internet. We defined a film temperature, a surface temperature. We defined the qualities of the air and the properties of the air for the heat transfer. You could see our U infinity is basically the speed that we traveled on the bike. I assumed that the air around us was still and that the only convection that was happening was through us moving actually on the bike. We defined pressure and then we called some external floor to get a heat transfer coefficient. One thing to look at for these type of calculations is the Biot number, which came out to around 7, so we could know that the lumped capacitance model is inappropriate. We did some more definitions. As you could see here, we only did 3 iterations of the full calculations for the not lumped capacitance model because that seems sufficient, and I think anything beyond 3, the numbers wouldn't change significantly. We defined the temperature of the skin using the equation down below, T infinity plus Ti minus T infinity times the summation of those 3 terms above. And we could also define the convection. If we're assuming convection is the only heat transfer happening and that we don't have any heat being generated, the temperature of the skin, which remember is very close to the surface and not representative of my entire head, it drops drastically with time. So you could see after that 5-minute ride, without any heat generation, the temperature of my skin would be almost freezing, which obviously isn't what happened. We can also do some radiation calculations so we can see that we define the temperature of the sky, the sun, and the surface of our skin. Our G value isn't very large since it was the morning, and we could also define all the other parameters that go along with this. The critical wavelength of our skin came out to 3.7 microns, which was found on the internet, and you could see our setting up our fractions and our alphas, and then setting up the equations to calculate the radiation from the sky, the radiation from the sun, and the radiation out of our skin, and then putting them together to get a final number for total heat transfer. Looking at our solution, 70 watts of heat come out of our face from convection, which seems like a lot, but it is very cold and it does make my face sting. And then when we factor in the radiation coming into our face, it comes out to about 45 watts. For a quick reality check, an iPhone 12 can be powered with 20 watts, so the heat from our face could power 2 iPhones, theoretically speaking. Furthermore, the average basal metabolism is 80 watts, which for reference, this 45 watts wouldn't be enough to kill us, but keep in mind that's only coming from our head, not our entire body. While there was plenty of opportunity for error in this experiment, we can conclude that our calculations support our experimental data as well as the measurements taken by the thermometer during the experiment. We also assumed that our head was a perfect sphere and that there was no insulation from our hair, but furthermore, this heat transfer lesson shows how applicable it is to our everyday lives. Thanks for watching.